Zero is my hero.
Welcome to the adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl like Kid Calculus and the Daring Derivative.
But till you came along, we counted on our fingers and toes.
Okay, now we're going to be doing ellipses. Remember, the general form of a circle was this, where the coefficients in front of your x squared and y squared term are the same. An ellipse, your coefficients are going to be different. This is your simplest form of an ellipse when your center is at the origin. They still use the term r squared even though there's no radius. But the main thing to know, how you know an ellipse is different than a circle, is because your coefficients in front will be different. They will be different coefficients, not the same. Your numbers will not be the same. These will be different numbers, okay? And when your center is not the origin, then the general form looks like this. Looks pretty much like a circle, except you have different coefficients here, okay? So when A is 0, and B is 0, when your centers are the origin, x minus nothing is x, which gives you the x squared. Y minus 0 is just y, and then squaring it gives you the y squared. That's why this is a simple form where the center is the origin. This is when the center is not the origin. So again, the main difference between ellipse and circle: circles have the same coefficients in front of your x and y squared terms. Ellipses have different coefficients. So let's look at 23C, 7 through 10. You have this equation here. 6x squared plus 4y squared equals 24. I know it's an ellipse because my coefficients are different. If this was a 6 and a 6, then it would be a circle. Or if they were both 4s, it would be a circle. But because the numbers are different, then it's an ellipse. If I wanted to put it in that general form to see what the center is, in the most simplest form, your center will be the origin. But this is why. Because if I put a 0 there, x minus 0 is just x, which gives me x squared. Plus 4, y minus 0. So, seeing here, I can see that the center is 0, 0. We don't take the square root of this to get the radius. For an ellipse, there's no such thing as a radius. Okay? So, when we have an ellipse, I'm going to erase this for a second just to eliminate any confusion. I just wanted you to see how I got the center. When you have an ellipse, we have to calculate what's called the extremity points. So when you have an ellipse, it's either going to be up like this or it could be horizontal. We are wanting to find these extreme points in order to graph our ellipse. Alright? So if you're on a graph, and you're right here. So if my center was the origin, then here, these points, my x-coordinate would be 0. I didn't go anywhere in the x direction. Up here, I didn't go anywhere in the x direction. So my x-coordinate is 0. Here, I didn't go anywhere in the y direction, so it's going to be some number and then 0 for y. And then over here, some number and then 0 for y, because my y coordinate is 0. Okay? So, and of course this is when your center's at the origin. Basically what you're doing when you're calculating these extreme points is you want this term to be 0. You want it to go away, and then you'll do the same thing for the other one. So, if I want this whole thing to go away so I can solve for y, because what I'm trying to do is find coordinates. So if I want this whole thing to go away, what does x need to be? X needs to be 0, because 0 squared is 0 and 0 times 6 is 0. So if I come over here and make a little chart so I can keep up with this. So in order for that first term to go away, I need x to be 0. So when x is 0, so basically if I'm putting in 0 for x, I want to know what is my y value when x is 0. When x is 0. Well, when x is 0, that whole thing goes away. So now I'm just left with 4y squared equals 24. And I'm trying to solve for y. So divide my 4 over. So y squared equals 6. How do I solve for y when I have a square? What's the opposite of square? Square root. I have to take the square root of both sides. When I do that, what do I put in front of my square root symbol? Plus or minus. So this side just becomes y, and this becomes plus or minus square root of 6. And if you do square root of 6 into decimals, because when you're graphing, you're going to need to put it in the decimal. So it's approximately 2.5. So when x is 0, what I'm saying is I've got a positive square root of 6, which is 2.5, and when x is 0, I also got a negative 2.5. You should be coming up, when you do these extremities, you should be calculating 4 points, because you're going to have your center, and then you have 2 points on each side of your center going up and down, and then 2 points from your center going out to the right and to the left, even when your center is not at the origin. So we found those 2 points when x was 0. Now let's go back to the original problem. The first thing we said was let's let that term go away. Now let's let this term go away. How do we get this term to go away? Y has to be 0. Okay? So in the very first step, I should write here, let's let x equal 0. Okay, that's what we did. Now we want this term to go away. In order for this to go away, y has to be 0. So now we're going to say let y equal 0. So then we have 6x squared plus 4, 0 equals 24. So when y is 0, 0 squared is 0, and 0 times 4 is 0, so that whole thing goes away. So now we have 6x squared equals 24. Divide both sides by 6. X squared equals 4. Take the square root of both sides. You got to put plus or minus in front of your radical. So going over this way, x equals plus or minus 2. So what did that tell us? So going over our little chart, we said when y is 0, when y was 0, I got a positive 2 and a negative 2. So when y was 0, I got a positive 2 and a negative 2. And these are the 4 points that we can plot for my extremities. 23C10, graphing our ellipse. Our center was 0, 0, so the origin, so always graph the center first. Then here was our extremity points, or our axis points, whichever one you want to call it. When x is 0, so in other words, when my x coordinate is 0, meaning I'm not going to go anywhere in the x direction, I went a positive and a negative square root of 6, which is approximately 2.5. When you have radicals, you need to turn radicals into decimals to know where to graph them on the graph. So when x is 0, I've got a positive 2.5, so don't go anywhere in the x direction, but go up 2.5. Then also when x is 0, negative 2.5, so that's going down 2.5. So when y is 0, I got plus or minus 2. So be careful when you graph this. This is your x coordinate, this is your y coordinate. So basically I have a positive 2, 0, so positive 2 in the x direction, going over 2, don't go anywhere in the y direction. Negative 2 in the x direction, negative 2, and then don't go anywhere in the y direction. And then that will be your ellipse. Okay, let's look at 23B7. So now we don't have the simplified ellipse, we have parentheses. When you have parentheses, that's going to tell you that your center is somewhere else other than the origin. Okay? So in order to get this in general form, this needs to be a subtraction sign. So if that was a subtraction sign, it would be 1 minus a negative 1, because minus a negative 1 would give me a positive. So now I can see that my center will be this number, 2, and then this number, because this is where I have the subtraction sign, negative 1. Finding the center of the ellipse is the same thing as finding the center of a circle. Okay, but now we don't have a radius on ellipse, we have to find the extremities. So how do we do that? We need the first term to go away. I want this whole thing to go away. What does this need to be in order for this whole thing to be 0? Can you see that my x needs to be 2? If this was a 2, I would have 2 minus 2 is 0, 0 squared is 0, and 0 times 4 is 0. So I need to look at this and say, what does x need to be in order for this whole thing to go away? So x needs to be a 2. So I'm going to write here, let's let x equals 2. So when x equals 2, here's what I have. 4, 2, I'm putting in my 2 for x. So that's what I'm doing, squared. I'm not doing anything to the y values because I'm going to I'm going to solve for y. So 2 minus 2 is 0. 0 squared is 0, and 0 times 4 is 0, so that whole thing goes away. So the only thing I have left is this. So I'm solving for y. Okay? So if I'm solving for y, first thing I want to do, get rid of this because it's being multiplied. Divide both sides by 16. So then I have y plus 1 squared equals 64 divided by 16 should be 4. How do I get rid of this? I'm squaring it. Take the square root of both sides. So that goes away. So I have y plus 1. What do I put in front of my radical when I take the square root? Plus or minus. So that should be a plus or minus 2. Now how do I get rid of the 1? Subtract it from both sides. So I have y equals plus or minus 2 minus 1. So you should come up with two different answers. What you have is you have a positive 2 minus 1, and then you have a negative 2 minus 1. So positive 2 minus 1 equals a positive 1, and negative 2 minus 1 equals a negative 3. So this is your y values. So we can make ourselves a little chart. So we said, what was x going to equal? You have to keep up with your notes. We said, let's let x equal 2. So when x was 2, we came up with two y values, and you should, because you're going to come up with 4 points. So when x equals 2, one of my y values was a positive 1, and one of my y values was a negative 3. Okay? Now we need to let the other term go away. First, we wanted this term to go away. Now we want this term to go away so we can solve for our x extremity points. So what does y need to be in order for this whole thing to go away? Can you see that y needs to be negative 1? If I had negative 1 plus 1, that would make this parentheses 0. 0 squared is 0, and 0 times 16 is 0. So we're going to let y equal negative 1. Okay? So let's let y equal negative 1. So when y is negative 1, we can plug that into our equation, not do anything to x, only we're going to do something into y. So if y was negative 1, then negative 1 plus 1 is 0, 0 squared is 0, 0 times 16 is 0, so that whole thing goes away. So the only thing we're left with is this. So we're solving for x. So divide both sides by 4. Then we have 16. How do we get rid of the square? Opposite, square root. What do you put in front of the radical when you take the square root? Plus or minus. So this becomes x minus 2 plus or minus 4. Now we want to add. So what that means is you have a positive 4 plus 2 and a negative 4 plus 2. 4 plus 2 is 6, and then negative 4 plus 2 is a negative 2. So remember we said when y is negative 1. So going over here to our little chart, we said when y is negative 1, we got two values. When y was negative 1, one of our values was 6. When y was negative 1, the other value was negative 2. These are our 4 coordinates that we can now plot for our extreme points. Alright, looking at 23b8, the center of our ellipse was 2, negative 1. We plot it first. Over 2, down 1. So there's my center. So now plotting my extremity points or axis points, remember, or not remember, but know that your extremity points or your axis points will be in line with your center. So I'm going to be going up and down from this center and then off to the right and to the left. They should line up with your center. So here's two of my coordinates, 2, 1. When x was 2, then I got the points 1, negative 3. So x being 2, go over 2 and then up 1. Oh wait, here we go. Over 2, up 1. You have to. This is your coordinates from the origin. Don't count from the center like we did with the circles. So that's the coordinate 2, 1. So you got to plot the coordinate 2 over 2 up 1. Now when x was 2, y was negative 3. So you plot that coordinate. Going over 2, down 1, 2, 3. So do you see how they lined up? So once you plot your points, they should line up with your center. Okay, so then we said y was going to be negative 1. When y was negative 1, then we got x to be 6 and negative 2. So don't plot your negative 1 first, even though we said y was going to be negative 1. So just plot the point 6, negative 1. So starting from the origin, going over 6, 1, 2, 3, 4, 5, 6, down negative 1. And then negative 2, negative 1, 1, 2. So when I plot it, it should line up with my center. So you don't have to count from the center, but when you plot these points, make sure that these points line up with the center, and there's your ellipse. Okay, we're doing 23D, 7 through 10. We have this problem right here. So the same as any other problem, if I asked you if you wanted to work with fractions, most of you would say no. So how do you get rid of fractions? Look at your denominators and see what you can multiply everything by for the denominators to go away. So I see I can multiply everything by 16 because 4 will go into 16. So I have to multiply everything by 16. This, and even on the right side of the equation. Alright? So here, 4 will go into 16 4 times. Here, my 16s cancel. So what I have left is 4 out in front of this parentheses and a 1 in front of this parentheses, but the 1 doesn't need to be written, equals 16. So that doesn't need to be written. So I know I have an ellipse because my coefficients are different. So now to find the center of the ellipse, it's just like a circle. This is already a subtraction sign, so we can see that one of my y coordinate will be 1, but for this to be a subtraction sign, it would need to be x minus a negative 3. Minus a negative means a positive. So therefore my center will be negative 3 and then a positive 1. So that's the center of my ellipse. Now we've got to find the extreme points. How do we do that? First, we let this term, we want this whole thing to go away to be 0. What does x need to be for this whole thing to be 0? Well, if x was negative 3, negative 3 plus 3 is 0. 0 squared is 0, and 0 times 4 is 0. So let's let x equal negative 3, because when x is negative 3, that whole thing should go away. So to prove it, x is negative 3, there's my x, plus 3, everywhere I see an x, I'm putting in negative 3. Nothing changes with my y's. So we leave that the same. So negative 3 plus 3 is 0. 0 squared is 0, and 0 times 4 is 0. So that goes away. So the only thing we have left is this. Y minus 1 squared equals 16. I'm solving for y. How do I solve for y? I need to get rid of that. Take the square root of both sides. So that cancels, and then I have a plus or minus in front of my radical. Don't forget your plus or minus. So now we have y minus 1 equals plus or minus square root of 16 is 4. Add your 1 to the other side. Okay, so then we have plus or minus 4 plus 1. What does that mean? It means a positive 4 plus 1 and a negative 4 plus 1. So our y equals 4 plus 1 is 5, and negative 4 plus 1, negative 3. So I can make me a little XY chart. We said we're going to let x equal negative 3. That was what we said at first. So we should be getting two values. So when x was negative 3, one of my y values was 5. When x was negative 3, the other y value was negative 3. So these are already two coordinates I can plot for my extreme points. Now we've got to find the other two coordinates. So how do we do that? First we said we wanted that term to go away. Now we need this term to go away. What does y need to be in order for all of this to go away? Y needs to be a positive 1. Positive 1, 1 minus 1 is 0, and 0 squared is 0, so that whole thing will go away. So we're going to say let y equal 1. So everywhere we see a y, we can put in a 1. So 1 minus 1 squared equals 16. So 1 minus 1 is 0, and 0 squared is 0, so that whole thing goes away. So the only thing we have left is this. So we're trying to solve for x. So first get rid of this, it's being multiplied, so divide it over. Okay, now we need to get rid of our squared. Take the opposite of that, square root. Remember when you do the square root, plus or minus in front of that. So those cancel, so you're left with x plus 3 equals plus or minus the square root of 4 is 2. Subtract 3 from both sides. We can combine numbers, so we can combine these. So what does this mean? This means a positive 2 minus 3 and a negative 2 minus 3. So x equals 2 minus 3 is negative 1 and negative 5. So going back to our chart, what did we say at the beginning? We said we were going to let y equal 1. Be sure and put this in the right column. Don't put your 1 in the x column. We said let y equal 1. So it needs to go over here. When y was 1, we came up with an x value of negative 1 and negative 5. And so now these are the 4 points that you can plot for your extreme points to be able to graph your ellipse. Okay, now we're looking at 23D10. We said that the center of our ellipse was negative 3, 1. So plotting that, 1, 2, 3, up 1. There's the center of my ellipse. Now for our axes points, or our extremities, the first thing we said was we were going to let x equals negative 3. And when x was negative 3, we got the y values of 5 and negative 3. So you plot these coordinates. So plot negative 3, 5. So going over 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. Next coordinate was negative 3, negative 3. So 1, 2, 3, down 3, 1, 2, 3. Those should line up with my center. It does. Then the next thing we said was let's let y equal 1. When y was 1, our x values were negative 1 and negative 5. So plotting these points, remember, plot your x coordinates first. So going over negative 1 and then up 1. Now negative 5, 1. 1, 2, 3, 4, 5, up 1. And those should line up with my center, and they do. And then you can draw your ellipse.